Hello guys, welcome to question 8 of our paper 2. In this question we'll be looking at a 3D trig context, as you can see on the board, and we are given some information based on this diagram. We have a vertical pole AD and the entire semicircle and the triangle here, they are on a horizontal plane, and therefore there's a 90-degree angle definitely at point A, forming right angle triangles, giving us the idea of Pythagoras theorem that can be used to when we need it. And we are also given an angle at A, 110 degrees. The fact that we have a semicircle, we recall some properties of circles, right? Diameter, radius, and obviously we do have those here. FAE is said to be a diameter, and therefore FA is a radius, AE is a radius. Center to circumference again there, AC is a radius, and AB is also a radius. Making this triangle what type of triangle? An isosceles triangle with these two angles both equal to 35 degrees. Okay, so what are we asked to calculate? The length of DB, which is actually a hypotenuse in this right angle triangle. So definitely Pythagoras will need to come into play there. And initially, what do we need to do? Work out the value of R and then link it to this triangle. Okay, what will help us? Definitely the cos rule. We have a side with a corresponding angle, so 9 squared is equal to r squared plus r squared minus 2 times r cos of 110 degrees. So this is 81 equal to 2r squared minus 2r squared cos of 110 degrees. We are looking for the value of r, so let us factor it out. R squared is equal to 2 minus 2 cos 110 degrees. Okay, and therefore if you divide both sides by it and take a square root, so r will look like this: 81 over 2 minus 2 cos of 110 degrees. Good. We now plug that into our calculators and find out what the answer is, the length of the radius, cos of 110 degrees. Make sure that your calculator is in degree mode, not the radian mode. Okay, so we have 5.4934856 meters. Okay, why am I using so many decimal places? It's because we're asked to round off to 4 decimal places in our answer, so we need a minimum of 5 decimal places to be accurate. Good. So we have the value of r. Okay, we have the 2 meters. We can definitely get the hypotenuse, which is our dB in this case. So it is 2 squared plus our answer square here, right? Applying Pythagoras, we have our answer now to be 5.8462 meters. Okay, so this was 6 marks, definitely straightforward, and I definitely know that if it was you doing it by yourself in the exam room, you will get 6 out of 6. All right, so not complex, definitely not difficult. So yeah, this takes care of A. Let us go to question B and see what's on the menu there. So in this question, we need to calculate the size of angle CDB, okay, right there. And we do recognize that 9 meters is a common side to the small triangle and the bigger one there. So we can still use the 9 meters in this current situation. And what do we know? DB, we got an answer for it. And actually, since A is the center, the property of equality is maintained even in the 3-dimensional space. So this is equal to DC. Okay, so this side is 5.8462. That side is also 5.8462. 2. So we have the two sides. We're looking for the included angle, but we have the corresponding side. So can we use the cosine rule? Yes. How? Like this. 9 squared is equal to 5.8462 square plus 5.8462 square minus 2 times 5.8462 all square cos of angle CDB. What do we take? Our calculators and calculate 9 square minus 2 times 5.8462 square divided by -2, 5.8462 all square. Okay, and therefore we have cos of CDB is equal to -0.1849709. Okay, cos of an angle is negative. In which quadrant is that happening? Quadrant 2 and quadrant 3. Maximum number or the maximum sum of the 3 interior angles of a triangle is 180. So definitely we're limited to quadrant 2. And therefore, by that understanding, we get the reference angle to be what? Cos inverse of 0.1849709 is 79.3406, and therefore angle CDB is equal to 180 degrees, quadrant 2 reduction formula, minus 79.3406 degrees, which gives you 180 minus 79.3406, which gives you 100.7 degrees. Okay, so this takes care of this question here. That is the magnitude of angle CDB. Good stuff, guys. So we are definitely going to continue question 9 in the next video, and I'll see you then. So thank you for tuning in, and keep well. Sharp, sharp.